Say this. I mean, the two big things with Tulip is short time to value. Focuses on the operator, but short time to value. And
the solution is never done. You're looking at a dynamic organism. Like it's all demand changes, products change.
You don't land and move on. You land and iterate.
I am such a believer.
All right, cool.
So real quick, I'll just introduce you.
Sure.
What's your actual role?
Ecosystem lead. I'm an ecosystem lead.
All right, so we're with Mark Freedman from Tulip, who's an ecosystem lead.
Yeah, ecosystem senior lead is my title, but it doesn't really explain my role really.
In my world, Mark is the guy who came up all excitedly and said, "Hey, I want to show you this UNS thing."
Yeah.
So interestingly, earlier during the keynote address, so we're at Operations Calling 2024. We're at the keynote address. Natan shows this up on during his presentation, what we're going to show you here, and it actually gave me idea at maybe 9:20 in the morning. I had this idea from seeing this visualization because I haven't seen anyone in a concise way be able to illustrate with their tool what UNS actually is. Like most people understand it conceptually. Mm-hmm. So it drove me to build another app that I'm going to use in our presentation later this afternoon. All right, so real quickly, walk me through what we're looking at here, and more importantly, why'd you guys build it?
Well, first of all, let me just kind of explain the place that we're in.
Okay.
My background's in manufacturing. I'm a Kaizen guy. Love it. This is a fake factory, basically. So we have over there discrete manufacturing, and over here this is life sciences. We're using Tulip, which is a composable platform. But last year at Operations Calling, I showed you a little box with HighByte, running AI, and Tulip.
Right.
The box is now the entire room, and we're inside of it.
Okay.
And everything's connected, all of our partners.
All right.
So we adopted a UNS. So what we're doing basically is, so over here we have a simulated environment where we have a production facility doing a bioreactor with Sartorius, a partnership. Over there we have an optics, Rockwell HMI. Over here we have a GE Wave bioreactor with a Tulip app that operates it. Then this information gets sent over to a laboratory. In the lab, does sample management. You're in a space that's representing a biomedical facility doing large molecule production. But we have a lot of different devices that are all coming in through different protocol.
Yep.
So bioreactor's Modbus with a telephone wire connected to an edge device from Tulip, and Sartorius, which arrived literally yesterday, has an onboard OPC UA. The other optics has OPC UA, and then meanwhile we're running apps which provide a lot of context. Like this Wave bioreactor and this bioreactor and optics, they don't care what batch number they're using. They don't know what the operator is. They don't have this context. And that context is so important for the batch record, for everything. So what we've done basically is we've integrated all this into our unified namespace, which I've come to love because it enables, in my opinion, democratization. It's like sustainable democratization. So when I'm a new person building an app, and like this happened today at Sartorius, so like I wanted to display my temperature on the Sartorius. So what do? In Tulip, I could, if I wanted to, go in and be like, okay, connect to the OPC UA server, where's the tag and whatever. No, instead, just connect to the UNS and figure out what cell you're in. You're in the Experience Center, Life Sciences, Bioreactor 2, Sartorius, temperature. Boom, it's on there. It's totally sustainable, easy to do. And now when on Sartorius, if they pick a batch that they're going to run, because again, that equipment probably doesn't care. Actually, it's really this equipment, it might care, but most wouldn't. When they select that batch, Tulip, on our common data model, which I can explain that, but Tulip has a common data model with composable MES. So when people download a app template, it's going to use the stations table and say, oh, you're using this batch? This automation sees that, ships it to HighByte. HighByte says, oh, I know this is context for this. Boom. So now I can just add any cell, any equipment, anything I want, anywhere, under any protocol, and I can access it and start building creative solutions to solve those problems.
All right, so here's something that really stands out from last year. All right, so last year, we were in a conference room over there. HighByte was here. HighByte is local. They're based in Maine. And HighByte are the guys that build the Intelligence Hub data operations platform, right? They're all formerly from Kepware, and they came to visit you guys. They came here. I was coming to visit. They came to visit. We were in a conference room there, and we were literally like, hey, you guys, like if you take HighByte and you connect it to Tulip, you take the two, it becomes like this superhuman platform for data operations. After Operations Calling last year, I think was the digital factory downtown, and that's when Natan did with Blake Moray.
Yep.
He did the fireside chat.
Yep.
And What's really interesting is now you have optics.
Yep.
Like you guys have the strategic partnership with Rockwell. You have optics integrated. You have HighByte integrated, and all of that happened in the last year.
Yeah.
Right. I
Well,
mean, it's
I had never, so like I said, I'm a manufacturing guy, so I always care only about the people on the shop floor making their lives easier. That's
Right.
all I ever care about. And this Tulip is just like the best problem-solving tool ever, so I had to use it. And I was never really in this world, really. You know, the first time I did a UNS really was this weekend or this week. But I found out about HighByte because of a customer of ours swears by it. And it's one of our best customers. I'm like, this is interesting. And then I heard you chirping about UNS all the time. And I heard, people have 2 stickers on their laptops. It's Tulip and HighByte. I'm like, I got to figure out what HighByte is. Yeah. What is it? And I love that. I love them. They're great.
As an operations platform, so HighByte does for data operations what Tulip does for automations on the plant floor.
Yeah, and just to explain the difference between these 2 HighBytes, HighByte also has an onboard MQTT broker.
Yeah.
And honestly, we have one too, you know, but I think theirs is better than ours. So we just chose to basically, I call it I shouldn't even say it, I'm going to say it. I call this a trash broker, not because it's a bad broker, but because we're sending trash to it.
Right.
Like, I work remote and I'm working with my team to get these things online. So last week I was like, Het, I need you to get these devices onto this broker, and I don't care what topic you put it on. Just name it something, send it there.
Right.
So it's just trash.
Worry about it when you get to the operation layer.
Hub is like, okay, I see all this stuff. I see OPC UAs. I see automations coming in with webhooks. I'm going to put this in a pretty space, and then that's it.
And then when it's time to build upon this infrastructure here, this is data infrastructure. Now what's happening is consumers access here. Everything's been cleaned, operated on. And now everything is coalesced and unified here. And now what you're in fact doing is you're streaming to Snowflake.
Our entire there's a lot of this diagram that's not even included. Like for example, over there, we're also updating the ERP, but that's not part of the UNS. That's exactly, although we could. It's not. So like, there's a lot of other integrations happening that we're not talking about. Like Snowflake, for example, is producing analytics, machine learning and stuff, and those insights are now actionable in real time. So there should be a line here that says, we noticed something about your demand profile because we're also looking at all of your tables and your ERP and this, and we see that people are going to start buying, I don't know, witch hats pretty soon because it's Halloween season right now. So it's going to tell you that you got to start ordering these, you know? So that machine learning algorithm is going to kick in, and suddenly the planner in their app is like, oh shoot, my Kanban sizes are busted. I need to update these, you know? And it's just like an alert on their daily management board. I'm not talking as much about life sciences because I love general manufacturing, but I like them both now. But there's a lot of cool apps you should see here.
And by the way,
how many you've seen.
And real quick for the life sciences folks, what you see here, validation, this is all pre-validated. So as we add consumers in, there's no additional validation step that goes into using that data.
So this is the library up here, right? So you can have templates, right? I'm not sure if you guys have seen this. We're releasing the life sciences composable MES. We released the general manufacturing composable MES during Hanover Messe.
Yeah.
That's been great because there's a common data model with it. This year, releasing the life sciences one. So there are templates. These templates were used to create the applications you're seeing here and the applications there. So we put our money where our mouth is, sort of, and we use it. And we also have this one comes validated out of the box. So that demo there is the Weigh and Dispense demo right from the library, some customizations, and then done. And the Weigh and Dispense station is right here once it loads, So the reason why, like if you want to have UNS, all you do is download these and then it's in your, just point to your UNS.
That's slick, dude. I mean, I absolutely love, this is and then if you take this and you couple it with what's in your control room in there, shows all the instances.
Yeah.
Right now, imagine
a
Prezi presentation that allows me to click on an instance and then view it. I liked how you said last year it was a box, this year you're inside the box. Like that's a really good way to illustrate. Because the big challenge in unified namespace, and actually in anything in our industry, is how do you communicate to someone who doesn't understand the potential, all the things they need to know in order to understand the potential, right? Like when you talk about data contextualization and normalization, right? The fan speed RPM, the fan set RPM, and the air face velocity, they don't change at the same rate. So if what I wanted to do was write a model, in general, if I want to write a model that where I am training, you'll notice 2 changed and the set didn't, okay? I have to contextualize it first. Hey, these are the 3 parameters for laminar flow hood. But then I also have to normalize that data. I'm not going to explain to somebody that here it's natively normalized. So for every transition, every time airface velocity changes, let's say this is the highest resolution, this is 60 hertz, and this is 1 second, and this is once every work order, then I can normalize this for training in an ML model. Now, when I'm proposing UNS to somebody, and no one understands the value of machine learning, and so all they say is, I want to take these data points, I want to put them on there, and I want to be able to, I want to have the work order and those data points, and I want to be able to adjust them and then scan the barcode. How hard, it's so difficult to explain to somebody the value of the underlying architecture for all the things in the future you're going to want to do that you don't want to do today.
Like for this thing here, I can't, this is I'll just go back. Well, I'll go back here. Remember I started this batch earlier? Now I need to actually move forward, and I can't move forward unless I do certain things like turn the air off.
Right.
And now that updates, and now I can move forward. I can change the set point, and this makes it really accessible for the person who wants to control that.
Right.
Because, and I learned this, I guess I learned the value of UNS through this abbreviated burst of creating apps for this experience center, was because some of these ones, when I first hooked them up, I went from wave bioreactor to edge device, and then Tulip lets you just connect to this. So I just made this the machine, and that was fine. And I thought, okay, no big deal. But then when I was under a time crunch, when Sartorius asked me today, I went right to the UNS. I was like, forget finding out any of that stuff. Like I won't go anywhere else for it.
Right.
Because it's just there and it's reliable.
That becomes the shoulders upon which you stand for your next solution.
I don't have to worry about this.
Right. It's that and this when we talk about iterative development, that's what we're talking about. You're iterating. You never want to have to undo technical debt or redo. Like in the old days, we would only acquire the data in completely unstructured for the specific use case we had at that moment.
Right.
No. What we do is we create data infrastructure, and then we iterate on data infrastructure, solving problems over and over and over again.
If you want to test something,
and it grows.
Like I made the wave bioreactor in my kitchen. This demo was done in my kitchen, and at that time, I didn't have the UNS, and I was like, you know what? I'm just going to connect to it directly. And if you're going to do a first land use case, go for it.
Right.
But if you think that that's going to add, if you think that adds value and it does, and you want to do that to the rest, if you want to change your facility,
right.
I mean, you should do that.
You guys did an awesome job.
The example, the analogy I've used for the way I'm thinking about it now, because I'm like fresh eyes, like a baby looking at this stuff. It's the difference between having a desktop with all your folders, files and folders right on your desktop, and having folder structure.
Right.
And like, which one's better?
I used to use this. The UNS is like a file share for your data, except it is driven by all the things that create the data. So I used to say, when I bring Stephanie on board, and I have to get Stephanie to the data she needs to do her job. The old way was I had to teach you all the things that we had created with all the data and where they are. You go to this spreadsheet, you go to this report, you go to this website. No, now what we do is we create semantic hierarchy. We put all that, even the website itself can be a link in a unified namespace. Yep. So I can say, let's say we're looking at business development here, I can have, under the bioreactor, I can have links underneath the bioreactor to documentation for the bioreactor itself. You guys don't happen to have that there, but that's a very, very common use case where now the bioreactor is an object that contains all and then we call that an informative namespace, something that I'm only going to consume. What it is, it's about creating structure for all the data and events in a business and then teaching people how it's structured. And then so that they know where to put the new stuff and where to go get the old stuff.
And the structure is great, but it's also like the thing you're structuring is just very cool stuff objectively. I'm structuring like the setting, the actual machines and physical processes. And a cool thing about the way that Tulip is entering the space is that it's bringing a very important missing piece, which is like the context of why it matters, what you're doing. Because previously, as far as I understand, and correct me if I'm wrong, is really just like, I don't know, data geeks who care about their machines, you know?
Right.
And I'm probably wrong with that, but like...
No, you're right.
Okay,
you're right.
but like, because I never nerd about it before, and but anyway, like with Tulip, we're all about the human, and that's why it so matches and aligns with my personal philosophy, because I just care about the operator. And they don't. If I say UNS to someone on the shop floor, they don't care. They're like, where's my part? That's what they care about. And like that information is entering the story. Right. Welcome to the UNS human.
Awesome. It looks great, Mark. I appreciate it.
It's great talking to you.
Thanks for the time. All right.
My whole mission, I guess, is it's ubiquitous in our consumer everyday life. Everyone has. We're all cyborgs. We have a phone. Yeah. I can order pizza.
I call us androids. I say we're literally androids.
I have a phone. I can order pizza. It shows up. I can get a taxi, and I know when the pizza's in the oven. I know it's coming out of the oven. Yeah. I get a taxi. It shows up, and then I get to my manufacturing facility, and I can't even tell you what they're working on the next cell over. I can't tell you that.
You're literally saying it's like literally the same. We're getting ready to do a workshop. Literally going to do a workshop next month on recruiting and retaining the employee of the future. And the problem we're answering is, why is it you can't hire young Gen Zs, Gen Millennials? And the answer is because when they walk into the typical manufacturing facility, they go 50 years into the past, and they go, "What? Wait a minute! I'm connected to this. I have access to all of human knowledge in my personal life. Like any question I want answered, I can have answered here. Yet,
ChatGPT, everything, all this stuff.
You can't tell me where my raw material is, or when that whip is going to get to my cell. So, I can't find it.
So here's the thing, who made Uber? It wasn't taxi drivers.
Right.
Right? It was tech engineers in Silicon Valley, right? They wrote taxis. It's a very similar pattern. Make a request, whatever, dispatch. That's a pattern. In manufacturing, if you look at the tapestry of use cases, you're not going to find a very repeatable pattern.
Right.
It's nuanced. And what you have to do is you have to solve it. And the tools you have are Excel, right? Whiteboards. Those are your tools.
The one thing you do is you ask people when you're going into a non-digital company, you actually ask them, give me all the spreadsheets you built to solve problems.
Right.
Because the spreadsheet is the one that shows you what the problem is.
Yeah. And you look at the boards, and you see these magnets and beautiful pieces of artwork on these boards. But it's like they need better tools. So insert frontline operations platform so you can solve your own problems. You know what I mean? Anyway, I want to show you a couple small tidbits. One, because I forced him to listen to me because I like to talk maybe, but also I love material systems use cases. And material variance, inventory variance is like you shut down your factory for a week, a day, doing physical inventory, whatever. You shut it down. It's a total waste. And the transactions, you don't want to do the transactions because that's a waste too. So I love Kanban for this reason, because when the bin's empty, you know something, So in this example, when you scan, I call it an estimation of a transaction. It's going to estimate the inventory number, because you're scanning, but someone could have came in and took that, and that happens all the time. Right. So what I'm going to do instead is I'm going to empty this Kanban bin. So I'll create the request. Never mind the fact that I just automation, UNS sent it to another factory. Now they have a signal, they can schedule it and all that. But it also showed up on that board because the number changed, right? The number changed, and it says that we thought you had 25. You actually only have 20 because you scanned the bin. So inventory person, you just got a discrepancy. Now we need to figure out which part number. Because it could be an issue with the bomb. It could be an issue with who knows what it is, Right. But that's how you correct for that. So it's like reactive cycle counting. Right. You know what I mean?
In real time.
In real time.
In real time.
Yep.
As the event is happening.
Yeah.
As opposed to reconciliation post factum.
Oh, because you can't get the data.
Right. Exactly.
I mean, half that variance that you see, you're just like, I'll get some people looking up what happened, looking at the ERP transaction. I don't know what happened to it. Maybe the bomb's wrong. And then
most people, how often do you come up here? You said you work in Greensboro.
Yeah.
How often are you up here?
Well, physically, I'm up here once or twice a month. I go to customers a lot still because I'm obsessed with being in factories and just kind of like figuring out what's happening. And
it's amazing how many young people actually are.
Oh my God, I'm addicted to it.
Like my Jared, my middle son, who's an engineer with the integrator I sold, when he first went on site, he said, I think I want to work in the plant more. Like I want to go and work at the customer.
It's so human and raw and real, because the thing I love about it is
that's where the problem is.
And you can solve them, and two, if you try and fake it, like you say, you're going to have to use this app, go back a month later and tell me if they're still using it. Because the truth is what happens.
Well,
Whatever is easier, whatever is better and easier is what stays.
That's your reality, right? The truth, what you say, truth is what happens. What happens is the reality.
Yeah.
And too many people are trying to solve the problem by trying to abstract the reality instead of collecting the reality. One of the values of Tulip I always say this. I mean, the two big things with Tulip is short time to value. Right.
Yeah, totally.
Iteration focuses on the operator, but short time to value. And when I say short time to value, I mean use cases that take a week in any other platform. You guys are doing in hours. Like so much of what we see here, I don't think most of the people who attend the show realize, holy shit, like the coffee thing was made last night.
Yeah, but you're
right. You know, like
you're also looking at it kind of. I'm not trying not to correct you, but maybe to add on to it, which is like the solution is never done.
It's never done.
You're looking at a dynamic organism. Like it's all demand changes, products change.
You don't land and move on. You land and iterate.
I am such a believer in continuous improvement, and there is no tool, in my opinion, like this because there's something special that happens when you are working with an operator or an associate who knows the process best, and you're trying to understand it, and they say, "I really want this," and you just drag it on the screen, and they're like, "I actually want this. I actually want that." Now
and then
build that.
You guys
culture.
added the generative AI.
Oh my God! This use case over here is awesome.
So now you can just say, "Hey."
I can show you. I can show you here. Actually, this is a good example of it. So when this cell goes down, right? I can put an and on light, right? Which, I mean, surprise, a light turned on, notifications. Okay, that's nothing new. This is kind of new because ChatGPT, I use it every day. That's how I built that UNS thing, was because I was like fighting with ChatGPT. I'm not like a coder, but if I'm waiting for someone to come help me, I can just ask a question. Hey, there's a printer issue, you know? Like, while I'm waiting, while I'm down, what do I do about this printer? And then it's going to look up the history of every other and-on and every other resolution that happened and say, did you try checking the ribbon? Because that might be, okay. And then guess what? That quality issue, or I guess it was equipment issue, I'm just going to fake generate some stuff. But like, yeah, that's resolved, and now the next person who has that issue, boom. Have you ever tried to make those trees of problem solving?
It's a nightmare.
It's not sustainable. It's not sustainable.
No, and that's the problem with the way most people are approaching generative AI solutions, is that they believe they can create a decision tree that's going to get you to the ultimate solution. No.
You need to augment. You need to help the human.
Right. You have to continue. You have to use machine learning to learn from the data, no matter without you knowing what data is coming.
Yeah.
Right. And so the beauty of large language models is that it finds patterns in words.
Yeah.
And when you say, go find me the pattern that matches the problem I have right now, it does that at 98, 99% accuracy.
Yeah. There's different types of AI. Like on this, and you know that, but on this station, the receiving inspection station, I mean, people who get invoices and have to type in the invoice, whatever, it's a different kind of AI, but it's like, just take a picture of it and just, ship it. Don't worry. Like, that'll take care of it for you.
Correct.
So you can use it in different ways too. But the language models are special because you can talk to them, and for like troubleshooting, problem solving, MRB, like, please, I changed the gasket. What else could it be?
And you guys have done the best job. I mean, seriously, you've done the best job of integrating.
Well, it even shows you the referencing. So like, it tells you to check the ribbon. It tells you to check the ribbon because on August 23rd, someone had that problem. So it's not making it up.
Right.
It actually.
The human's job is to confirm that it's not a hallucination. The human's job is to supervise the AI.
Yes.
The AI is not replacing the human being. This is a tool the human being is using to become a better human being.
Exactly.
Right?
So it's not like it's someone you can talk to help you until the engineer comes by and then types it in. But like, our engineer did a really good job because they force references. So we ask it questions that we know it doesn't have an answer to. And I guess the engineers beat it up if it told them something, because it says, I don't know, I really don't know, get someone else. So like, they intimidated the robot enough.
Awesome. All right, cool.
All right, I'll let you go.
Let's go eat.
Yeah.
I appreciate you, brother.
Yeah, I appreciate you
very much.
Thank you.
All right, let's go grab some.